Hi, so today we will talk about the property of a sample distribution of means. So in the sampling distribution model means when a random sample is drawn from a population with the mean mu and the standard deviation sigma, we have the following mean and standard deviation of the sampling distribution. The parent population mean is going to equals to the sample distribution means. And the sigma, the sampling distribution sigma, is going to equal to the sigma over the square root of the sample size. If you remember from the last classes, the simulation, the parent population is spread out more, whereas the sampling distribution also follow a normal distribution, but it seems more narrow, it's not spread out, because we use the standard deviation divided by the square root of the sample size. So regardless of the shape of the population distribution, the shape of a sampling distribution will be approximately normal as long as the sample size is large enough. But remember that from the central limit theorem, we also mentioned about if the population, when we talk about population, means the parent population is normal, no sample size condition is required. In this case, we will talk about that if the parent population is not normal, such as uniform or skewed. So here's some example. A person's measured glucose level 1 hour after ingesting a sugar drink varies according to a normal distribution, with a mu 125 milligram per dl per deciliter, and then a sigma is 10 milligram per deciliter. If a single glucose measurement is made, define and draw the distribution. What's the probability that a single measurement is greater than 140 milligram per deciliter? Okay, so remember this is a what? A normal distribution, which is follow mu equals to 125 and sigma equals to 10. So we know that the distribution is normal with mu and sigma. So in this case we have n follows mu is 125 and sigma is 10. And then we let x be the random variable of a person, a random person. Let's say let x be the variable of a random person glucose level. Okay, so we know that this is follow a normal distribution. Do you remember what does a normal distribution look like for the graph? It's going to look like a bell shape. The center is the mean, which is 125, and then within one standard deviation plus or minus 10, which is 135 and 115, that takes up what? 68% of the area of this bell-shaped curve, right? This should be 65%. And then for the second standard deviation, which is we add another 10, we have 145 and then 105. This is going to be 95% of the area. And then we have here is 155. A third standard deviation should be 99% of the area. So this is bell shape. So now we're trying to figure out, hey, what's the probability of that person? The measurement of the glucose is greater than 140. Then we use our GeoGebra. So in GeoGebra, we have our mu is 125, and the sigma is 10. And then we're trying to figure out when x is greater than 140. So we have 0.0668. Which is a 6.68%. You can convert it into a percentage. Okay, so if the measurements are made on 3 different occasions and the mean result is computed, discuss of each condition required to use a sampling distribution for average of these 3 results. So we know that the sample size has equals to 3 because they connect 3 different occasions. So now how can we, under what circumstance we can use a sampling distribution? So it has to meet the requirement of a central limit theorem, which is it has to be independent. Second, it has to be randomization. And third, the sample size has to be large enough. But remember, in our central limit theorem, the last sentence says, if the population is normal, no sample size condition is required. So even though this sample size is small, it's not large, and it's definitely a small number. But since we know that, hey, this is follow a normal distribution, so that means we don't need to consider the sample size. So that means they met all these 3 conditions. That means we can use a sampling distribution. So define a sampling distribution model and its parameter and draw and label the model relative to the model. Okay. So now let's take a look. Since this is following the sampling distribution, so what is its parameter? So we know that this is a symbol of the mean of a sampling distribution, which is equals to the population mean, and the sigma sub x bar equals to the parent sigma divided by square root of the sample size. So we know that the sample mean is equals to 125. We don't need to do anything. And then the sigma equals to 10 divided by sample size equals to square root of, sample size is 3. So it's 10 divided by square root of 3. And let's say this is equals to what? Use a Google calculator. We have 10 divided by square root of 3 equals 5.77. We round up to 2 decimal places. Okay, so now we still need to draw and enable the model relative to the normal distribution. So we know that this x bar follow a normal distribution. This is x bar means the sampling distribution with a mean 125 and the sigma is 5.77. So again, since this is normal distribution, we can draw the graph with a center 125, and then within one standard deviation would be what? 125 at 5.77, which is 113.577, and then subtract 5.77, we got 119.23. I hope I did that right. Let me use a calculation to double check. 125 minus 5.77. Oh, I got it right. And then subtract another 5.77 equals to, here, let me use a different color pen, which is 113.46, and then 2 standard deviation would be 113.77 at 5.77. Equals to 136.45. And this is follow a normal distribution. Okay. So this is our normal bell-shaped curve. And within one standard deviation, we have what? 68. This takes up 68% of the area. And then within the 2 standard deviation, they should have what? 95% by the imperial rule. Oops. It takes up 95% of the area. So this is the sampling distribution that we have. Okay, so what's the probability that the mean of these 3 measurements is greater or equals to 140? So remember, when they ask you, is asked about the 3 measurements. Okay, that means when we consider it, it has to be in the sampling distribution. So again, we know that this is following a normal distribution with a mu 125, sigma is 5.77, not the parent function, because we are trying to estimate the probability that of the mean of these 3 measurements. So we have the probability of x bar, not x bar, greater than or equals to 140. And now let's look at our GeoGebra. So instead of 10, our sigma becomes 5.77. And when x greater than 5.77, the probability would be what? 0.0047, which is really less likely to happen, which is 0.47%. Okay, what if the 95th percentile of the average of these 3 results from a person? So remember, what is 95th percentile? That means we're trying to find the cutoff value that the cutoff value is greater than 95% of the other value. So on the graph, it should look like, we know that this is going to be 19, and then we're trying to find this cutoff value. I don't know, let's say star. Whereas from the star to the left, this takes up 95% of the area of the bell-shaped curve. Okay, so again, let's look at GeoGebra. So we're trying to find less than, and we change this to be 95. So we have the cutoff value, x equals to, the average equals to 134.49. So that means if the glucose measurement is 134.49 milliliter per deciliter, that means it's higher than 95% of other people. Okay, so next time I'll give you more example about what is sampling distribution of mean. I'll see you next time. Let me know if you have any questions.